Beneath the surface of our oceans, a boundary is breaking. We have always trusted a simple map. Sunlight belongs to the shallows. Darkness belongs to the deep. Between them, an invisible ceiling, a threshold no creature was supposed to cross without reason. The animals of the abyss stayed in the abyss. The animals of the shore stayed in the shore. The ocean, we believed, obeyed its own vertical law. That law is failing. Along coastlines from Japan to California, from Norway to New Zealand, fishermen are pulling up creatures they have no name for. Divers descending only a few meters are meeting eyes that belong a kilometer below them. Tide pools, the shallowest, safest edge of the marine world, have begun offering up bodies that should have decomposed long before reaching sunlight. Something is rising, something that was never meant to be here, and we do not fully understand why. We have mapped more of Mars than of our own ocean floor. Less than 5% of the deep sea has been directly observed. And yet, from this vast unknown, its inhabitants are now arriving at our shores quietly, steadily, in numbers that were unimaginable a generation ago. What was hidden is surfacing. What was distant is close. The boundary we drew between our world and theirs is dissolving, and the creatures on the other side are the first to know it. This is not a single event. It is a pattern. To understand what is happening, we must first understand what was believed. For most of the 20th century, the ocean was pictured as a stack of sealed rooms. The sunlit zone, warm and productive, reaching down about 200 meters. Below it, the twilight zone, where light thinned into blue and photosynthesis ended. Deeper still, the midnight zone, where the sun ceased to exist and creatures generated their own faint glow. Beneath that, the abyssal plain. Beneath that, the trench's Hades itself. Each zone had its temperature. Each zone had its pressure. Each zone had its residents. And the residents, according to the old model, were prisoners of their conditions. A fish evolved for 4 degrees Celsius, and crushing dark could not survive the warmth and brightness above. A jelly built for stillness could not endure the churn of surface currents. A predator adapted to hunt by chemical trace in perfect blackness would go blind in the shallows. The vertical law was not just geography, it was biology, it was destiny. And yet, in the last 2 decades, that destiny has begun to bend. The first cracks appeared in the fishing logs, deep water species turning up in nets, set for coastal catch. Oarfish, serpentine giants that live hundreds of meters down and are almost never seen alive, washing ashore intact in Japan, in Mexico, in the Philippines. Frilled sharks, an ancient lineage so rarely encountered that each sighting becomes a scientific event, appearing at depths where recreational divers swim. Ragfish, football fish, black-scaled dragonfish creatures, once known mostly from museum jars, and grainy submersible footage arriving on beaches with their eyes still intact, their bodies not yet ruined by the pressure change. Then came the swimmers. Off the coast of Southern California, a diver filmed a football fish, a black, orb-shaped anglerfish from the midnight zone, pulsing weakly in less than 10 meters of water. It was not dead. It was not dying quickly. It was simply there, in a place it should not have been, in light it should not have survived. In Norway, a shrimp trawler brought up a snailfish species, previously documented only near the edge of the Hadal zone. In Tasmania, deep-water sharks began appearing in bays. In the Mediterranean, midwater squid, known for their reclusive habits, started stranding in numbers that broke every existing record. Then came the footage that stopped biologists cold. Off the coast of Tenerife, in early 2025, a small research boat filmed a black seedville, a species of anglerfish that lives more than a kilometer below the surface, drifting in broad daylight, meters from the hull. It was the first time the adult female of that species had ever been recorded alive in surface waters. The footage traveled around the world. Marine biologists watched it in silence. The fish did not flee. It did not descend. It simply hung at the surface with the sea around it, illuminated by a sun. Its lineage had never evolved to sea. It died shortly after. But before it did, it gave us the clearest single image yet of the phenomenon we are still struggling to name. Individually, each event could be dismissed. A sick animal, a lost animal, a statistical accident. Together, they form something else. They form a pattern the ocean has never shown us before. To read that pattern, scientists have had to unlearn what they thought they knew about the boundary itself. Because the boundary, it turns out, was never a wall. It was a current, a living veil made of temperature layers, oxygen layers, pressure gradients, and light, and every one of those layers is now shifting. Consider temperature. The deep ocean has always been cold, near freezing, at abyssal depths, stable for millennia. But the surface is warming, and as the surface warms, the thermal layers beneath it stretch, thin, and reorganize. The invisible ceilings that once held deep species in place are lifting. What used to be a 200-meter twilight boundary is, in many regions, now shallower. The cold water a deep fish requires has crept upward, and the fish has followed it. To an oarfish, it does not feel like migration. It feels like standing still while the world climbs around it. Consider oxygen. Across vast stretches of the global ocean, oxygen minimum zones, regions where dissolved oxygen collapses to near lethal levels, are expanding. They are thickening vertically and creeping horizontally. Deep-sea creatures adapted to low oxygen conditions can survive inside them. Shallow creatures cannot. The result is a slow inversion. In places where oxygen has drained from the middle waters, the deep animals move up because their tolerance zone has risen. The shallow animals retreat because theirs has been squeezed. Whole vertical communities are inverting, and the deep is winning the trade. Consider light. Coastal waters have grown murkier in many regions from runoff, from algal blooms, from sediment stirred by intensifying storms. Turbidity reduces light penetration, and for a creature evolved to see in near darkness, murky, shallow water is no longer intolerable. It has become livable. The barrier of brightness that once burned deep-sea eyes has, in some places, softened into a gloom that mimics home. The boundary was never a wall. It was a set of conditions, and every condition is negotiable now. But shifting layers alone do not explain the strangest arrivals. Something is pushing from below as well. Deep-sea currents, the slow planetary rivers that move water from the poles across the abyssal plains, have begun to alter their pathways. Some of these changes are documented. Others are inferred from where organisms end up. Larvae from midwater species have been found in surface plankton samples thousands of kilometers from any known adult population. Gelatinous creatures that drift passively are washing ashore on coasts that have no history of them. The conveyor belt is bending, and the passengers are being delivered to the wrong stations. There is another force worth naming, one that rarely reaches public awareness: the ocean's great eddies. Mesoscale spirals of water, sometimes hundreds of kilometers across, that spin off from major currents and travel across entire basins for months at a time. These eddies are not surface phenomena. They reach downward, sometimes to a kilometer or more, and they pump. They pull deep water upward at their centers or edges, and with the water, they lift plankton, larvae, and occasionally full-grown animals. Recent satellite altimetry suggests that some of these eddies are intensifying, lasting longer, and traveling farther than they did a generation ago. The deep is not only rising on its own. In many places, it is being lifted. There is a phrase that has begun to appear, quietly, in the recent literature. A phrase used when researchers cannot yet name a cause but can no longer deny an effect. The deep is no longer sealed. Once, that was a metaphor. Now, it is an observation. Consider what has been documented in the last decade alone. In the Sea of Japan, a region long thought to be one of the most stable deepwater basins on Earth, midwater fish communities have shifted their vertical range upward by an average of dozens of meters. Off the coast of Chile, deep-sea jellies have begun arriving in coastal fisheries in swarms. In the North Atlantic, deepwater sharks, tagged at depth, have been recorded rising into surface waters at frequencies never previously logged. In the Gulf of Mexico, following pressure and temperature anomalies, species from more than a kilometer down have appeared in shelf-depth nets within weeks. None of these events are, on their own, catastrophic. They are simply wrong. Wrong in the way that a compass slowly turning is wrong. Wrong in the way that suggests a magnetic field is shifting somewhere beneath the instrument. And still, we do not fully know why. There are candidate causes, and the honest answer is that several are likely working at once. Warming surface waters, expanding low oxygen zones, altered deep currents, overfishing of midwater predators, which may have released deep prey species to rise unhindered, noise pollution, which travels farther through deep water than through shallow, and which may drive sensitive species away from their traditional depths, chemical changes, acidification, working its way downward, plastic fibers working their way up. Each mechanism is real. Each mechanism is measurable. But no single one, in isolation, accounts for the scale of what is being observed. What is emerging instead is the picture of a system under simultaneous strain from many directions at once. And in such a system, the deep is not a stable basement. It is the floor that begins to move first, because it has fewer refuges left. There is another dimension to this that is easy to miss. Some of the creatures now appearing in shallow waters are not lost. They are not dying. They are foraging. They are breeding. They are hunting. In several documented cases, deep-water squid have been recorded predating on surface fish species in ways that were never before observed. Deep-sea sharks have been filmed rising into coastal waters at night and returning to depth by morning, a vertical commute of hundreds of meters, undertaken not by exceptions, but by populations. This suggests something the old model could not accommodate. It suggests that the vertical law was never absolute for the animals themselves. It was absolute for our ability to see them. As long as they stayed in the dark, we did not know. Now, as conditions push them into observable water, we are discovering that the deep was always more mobile than we allowed ourselves to imagine. There is a rhythm the deep has always kept, and it is older than any measurement we have of it. Every evening, across the entire world ocean, the largest migration on Earth begins. Billions of tons of small fish, squid, and crustaceans rise from the twilight zone toward the surface to feed under cover of darkness. Before dawn, they sink again. In 1942, sonar operators tracking submarines first mistook this migration for a solid seafloor, a false bottom that rose and fell with the sun. They called it the deep scattering layer. It is, in truth, a curtain of life pulled up and down each day, and it has been doing so for as long as there have been vertebrates in the sea. The vertical law, then, was never absolute. It was a rhythm we were too slow to see. The rise we are watching now is what happens when that rhythm slips out of phase. That is a humbling thought. It means the model we built of the ocean's vertical structure was, in part, an artifact of our own blindness. The wall we drew between the deep and the shallow was drawn where our instruments failed, not where the life divided. And now, as the instruments improve and the conditions shift together, we are seeing what may have been happening, in smaller degrees, for far longer than we knew. Still, the acceleration is real. The frequency is climbing. The strandings, the sightings, the anomalous catches, they are not returning to baseline. They are compounding. There is a creature that has become, without intention, the symbol of this shift. The oarfish, long, ribbon-bodied, silver-scaled, with a crimson dorsal fin running the length of its spine. It lives in the mesopelagic dark, and in traditional Japanese folklore, its appearance at the surface was said to precede earthquakes, a messenger from beneath, arriving only when the deep was disturbed. Modern science has found no reliable link between oarfish strandings and seismic events, but the myth is doing something else now. It is describing a pattern we did not have language for. A creature from below arriving at the surface as a signal that something, somewhere down there, is no longer as it was. There is one lineage of animals that has always defied the vertical law, and it has been doing so in plain sight. The sperm whale, the deepest diving mammal, descends to more than 2 kilometers on a single breath, hunting squid in a darkness we cannot enter. Beaked whales dive deeper still, sometimes staying below for hours. Every day, these animals braid the zones together, carrying nutrients up and behavior down. In recent years, several beaked whale species have begun stranding on coasts far outside their known ranges. Their inner ears show signs of acoustic injury. Their stomachs, in some cases, hold prey species they should not have encountered. They are, in a sense, the deep's oldest messengers, and they are increasingly arriving broken. If the whales are struggling, the water they hunt in is changing. The messengers are multiplying, and there is a further layer to this rising, one that reaches beyond biology into something more difficult to name. Because when the animals of the deep begin arriving in the shallows, they bring with them information. Information about pressure gradients we cannot instrument. Information about oxygen collapse we cannot fully map. Information about currents we track only in fragments. Their bodies, appearing where they should not appear, are data points from a system we cannot enter ourselves. Each stranded oarfish, each surface-swimming football fish, each unexpected snailfish in a shallow net is a note passed up from a room we cannot see into. We are reading the notes. We are still learning the language. There is a quieter form of evidence too. Around the world, oceanographers have been deploying hydrophone arrays, long strings of underwater microphones that listen for weeks or months at a time. In several of these recordings, biological sounds once cataloged only from great depths have begun to appear at shallower stations. Clicks, low mechanical pulses, patterned calls whose sources have not yet been matched to any known species. The animals are arriving. Their voices are arriving first, and we are listening to a chorus we do not yet know the singers of. There is a sobering echo in all of this. The deepest trenches on Earth already contain evidence of our reach. Plastic fibers have been found in the guts of amphipods living 11,000 meters down. Chemical signatures of surface industry have been detected in hadal sediments. For years, this was framed as the tragedy of the descent that even the most remote habitats on the planet were touched by what we discarded above. What we are seeing now is the ascent that follows. The deep is not only receiving, it is returning. It is sending its inhabitants upward into our nets, our tide pools, our coastal videos, our fisheries, and whatever we have done to it, we are now meeting face to face. The deep is no longer sealed. There are questions this leaves open, and they should be left open honestly. We do not know how much of the current rise is driven by climate versus current shift versus fishing pressure versus something not yet identified. We do not know whether the deep populations arriving in shallow water can survive there long term, or whether we are watching a slow collapse rather than a migration. We do not know whether the ecosystems above can absorb these new arrivals without cascading changes of their own. New predators in old waters, new prey in old mouths, new competitions we cannot predict. We do not know what the deep will look like when enough of its inhabitants have left it. And we do not know, most unsettlingly, whether what we are witnessing is unusual on the timescale of the ocean itself. The deep sea is old, older than continents in their current shape. It has passed through warmings and coolings, extinctions and recoveries, migrations we will never reconstruct. Perhaps the vertical law we believed in was only the appearance of a particular quiet century. Perhaps the rising we are now watching is the ocean returning to a rhythm older than us, a rhythm we simply had not lived long enough to see. The clearest analog we have lies 56 million years in the past. In the sediment cores drilled from the ocean floor, there is a thin, unmistakable band that records what geologists call the Paleocene-Eocene thermal maximum. In a span of a few thousand years, a heartbeat, in geological time, the planet's surface warmed, the oceans acidified, and something happened in the deep. As much as half of all bottom-dwelling foraminifera, the tiny shelled organisms that carpet the abyssal floor, went extinct. Whole communities vanished. The survivors reorganized. The event left a scar in the mud that we can still touch today. It is not proof that we are living through another such moment, but it is proof that we could be. And it is proof that, when the ocean changes at this scale, the deep feels it first. That thought does not resolve the mystery. It deepens it, because whether this rising is new or ancient, whether it is our doing or the planet's own, the message is the same. The boundary was never permanent. The deep was never distant. The creatures we imagined locked away in the black are moving, and their movement is telling us that the ocean is one ocean, not many. That what happens in the trenches touches the tide pools, that what we do at the surface reaches the abyss, and that the veil between the two is thinner than we ever allowed ourselves to believe. Somewhere tonight, along a coastline that has never seen one, an oarfish is drifting into the shallows. Its long silver body catches the moonlight for the first and last time. It arrives without violence, without warning, without explanation. By morning, someone will find it. They will photograph it. They will wonder what it means. It means the deep is rising. It means the map we drew was a guess. It means the ocean is speaking in a language older than our science, and we are only beginning to learn the alphabet. And somewhere below that oarfish, in water we have never seen, another creature is starting to climb, and another beneath that, and another beneath that, a slow, patient ascent from a world we were never meant to see into a world we thought was ours. The deep is no longer sealed. The messengers are arriving, and still we do not know what they have come to tell us.